In this video for section 4.4, we're going to talk about how to solve exponential equations. The first method that we're going to see is solving exponential equations by expressing each side as a power of the same base. And we've talked about this a little bit already, but if we have two exponential expressions and the bases are equal, then that means that for the expressions to be equal, the exponents have to be equal. So if b to the m equals b to the n, then m equals n. So to use this to solve, we need to have the equation in the form b to the m equals b to the n. Then we can set the exponents equal to each other and solve for the variable. So we're going to look at example 1. It says to solve, we're going to do part A, 2 to the 3x minus 8 equals 16. So what I need to do first is rewrite 16 as a power of 2. So 16 equals 2 to what power? Well, you could guess and check on your calculator if you don't know, but that would be 2 to the 4th power is equal to 16. So now I have the same base of 2, so I can set the exponents equal to each other. 3x minus 8 equals 4. And from here, it's a straightforward equation to solve. Add 8 to both sides and divide by 3, and I get x equals 4. So in the bracket that they're going to give you in MyLab Math, I would type 4. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer, and then move on with the video. Now, this method would only work if the exponential equation can be rewritten so that each side has the same base. That won't always be the case. So if we can't rewrite it so that each side has the same base, then we use logarithms to solve, and this is the process. First, we get the exponential expression by itself if it isn't already. Then we take common log on both sides if the equation has a base of 10. We use natural log for bases other than 10, especially base e. We want to use natural log. This is what the book says. You could use common log for a base other than 10 as well. It doesn't really matter that much, but I'm going to follow the process that matches what the book does. So now we can simplify using one of the following properties. ln of b to the x, we can move the x to the front and have x times ln of b. ln of e to the x is just equal to x, and log base 10 to the x is also equal to x. Then we can solve for the variable. So for example 2, part A is 4 to the x equals 15. Now notice that I can't write 15 as 4 to some power because that wouldn't be a whole number. There's no power of 4 that equals 15. So what we're going to do is take natural log of both sides. So ln of 4 to the x equals ln of 15. Now I'm going to use the property, the power rule, and move the x to the front here. So I have x times ln of 4 equals ln 15. And lastly, to get x by itself, I would divide both sides by ln 4. Since x is multiplied by ln 4, I would get rid of ln 4 by dividing. ln 4 is just a number. It's kind of an ugly looking number, but it's just a number. So that cancels out, and we have x equals ln 15 over ln 4. Now the homework is going to ask you to enter an exact answer, and this is what you would type in first. ln of 15 over ln of 4. Then they're going to ask you for an approximation. And for the approximation, you would type this into your calculator, and you would get approximately 1.95. For these questions, MyLab Math is going to ask you to round to 2 decimal places. So you would need to enter this first and then the decimal approximation. For part B, we have 10 to the x equals 120,000. So now, since it's base 10, I'm going to use common log. So log of 10 to the x equals log 120,000. So basically you're just doing log or natural log of both sides of the equation here. Log of 10 to the x, using my property above, right here, log of 10 to the x is just equal to x. So x equals log 120,000. So this is the exact answer here, so I would type that into the homework first, and then on my calculator, I would type it in to get the decimal approximation. It's approximately 5.08. So next you should look at checkpoint number 2. Do these in your notes, check your answers, and then move on with the video. We're going to do one more example here that's a little bit more complicated, and that's example 3. So here we have our e to the power of 0.6x multiplied by 40, subtract 3 equals 237. So I need to undo these other things around the exponent first. So like if this were 40x minus 3, I would add 3 first and then divide by 40. So it's the same idea here. First I need to isolate the exponential part of the equation. So add 3 to both sides. 237 plus 3 is 240. And then divide both sides by 40. And I get e to the 0.6x equals 6. Now, once I have it so that I have just the base and the exponent on one side, now I can take natural log of both sides. Since it's base e, I want to do natural log. That's going to be the easiest. So natural log of e to the 0.6x equals natural log of 6. Now natural log of e to the 0.6x, that's just going to be 0.6x. So it would be equal to the exponent. So then I have 0.6x equals ln of 6. And lastly, to get x by itself, I would divide. Now notice I'm keeping this ln of 6 as it is right now. I'm not getting a decimal approximation for that. And that's because the homework is going to want you to enter an exact answer. So they would want you to type in ln of 6 over 0.6 first. That's the exact answer. And then I would do this on my calculator to get the decimal approximation of 2.99. So you're going to need to enter both of these into the homework. So next you should look at checkpoint problem number 3. Do this in your notes, check your answer, and then move on to the homework.